Okay, this is the next Prelab. This will be Prelab 4. And this is actually what we're doing. We're combining magnesium, as I talked about in the other Prelabs, which were pretty much the same. And we're combining it with oxygen. And we're making magnesium oxide. And you know that a non-metal oxide is called a what? Anybody know? Can anybody do it? Tom? T? Can you do it? You know what a non-metal oxide is? You can do it. I'm not mad because a lot of equation writing and the study of chemical reactions takes time for it to sink in. I'm not being mean. It's true.
Type of reaction?
No. What type of compound is a metal oxide? I'll give you a hint. Is it a oxide? Is it an acid anhydride? Is it a salt? Is it a base anhydride?
Oxide?
No. It is an oxide, but that's not the best answer. You got to be more specific. It's not an acid because if I put that in water, I develop a base. A base is defined, remember, by the OH. So if you have OH, if you have hydroxide, that's a base. If you have a free hydrogen, that's an acid. You can tell right by the formula, correct? Yes or no?
Yes.
Okay? And we're going to do that reaction after we finish the lab. Clear? So, magnesium oxide is a metal oxide, which is a base anhydride. Is that clear? Yes? Starting to make a little more sense, T? Yeah, okay, good. So, what I'm going to do is, we're going to first balance this equation because you can't just use an unbalanced equation to do a lab based on stoichiometric principles. Yes or no? Okay, so let's balance it. Let's make sure it's balanced. One magnesium, one magnesium. Good. Two oxygens. Remember, when the elemental oxygen is by itself, it's diatomic. It's O2, correct? It's not O. Yes?
Yes.
What are the only gases that are monoatomic and they don't really react? The heavier ones do, but the lighter ones do not. What are the only ones that are monoatomic as gases? The noble gases. Very good. What are the gases that are diatomic from the chart? It's the reds. Halogens, that's fluorine, chlorine, bromine, iodine, right? Yes? Even though iodine can be a solid, it sublimes. It goes from a solid to a gas, and when it's a gas, it's diatomic. Bromine is kind of a liquid gas at room temperature, but when it's a gas, it's diatomic. Chlorine is a gas at room temperature, fluorine, oxygen, nitrogen. When they're gases at room temperature, yes? And nitrogen and oxygen and fluorine, chlorine they are diatomic. So what do I need to do? I need to put a 2 here. Now I have 2 magnesiums, I put it here. Now I look up, well, what is the mass of magnesium? What's the mass number? Use mass numbers. Don't be complicated. Just use the mass number. What's the mass number for magnesium? Remember, you're young chemists. This is good. You're struggling. That's all right. Things are going to start to come together. 24. Excellent. 24 times 2. 48. What's the mass number of oxygen?
16.
16 times 2. 32. We can simply go 48 plus 32 is 80. Good thing to double check though that you did your balancing correct. Let's find out the mass of magnesium oxide times 2. What's the mass of magnesium? 24. What's the mass of oxygen?
16.
What's 16 plus 24? 40. What's 40 times 2? Is it correct? Yes. Does the left equal the right? You have to make sure the first step is that you're observing the conservation of mass. Sounds simple, right, T? But hey, what happens if you have an incredibly complicated reaction such as sodium iodide plus lead-2 nitrate yields sodium iodide plus sodium nitrate plus lead iodide? It's a little more complicated, isn't it? So this is simply an example. The techniques are the same. The examples just are a little more complicated, applying the same exact rules. Clear? Are you with me? Yes? Good. Excellent. So let's say we have 1 gram of magnesium. That's what we start with, 1 gram of magnesium. And we're going to determine the amount of magnesium oxide that we have. So you're going to predict, after you finish the lab, I just made magnesium oxide. Okay, all right, fair enough. Did I get the correct product? How much magnesium oxide should you get if you have 1 gram of magnesium? Well, let's examine this. I'm just going to go through this. Understood? This kind of lecture-like, I apologize, but I want to get through this. But I want you to appreciate this from an overview, and that we're just doing things that may make more sense now because of the pre-labs that we did last time we met. I'm comparing magnesium with magnesium oxide, correct? So it's going to be 2 magnesium over 2 magnesium oxide. Isn't that correct? Isn't that a constant ratio? What is the ratio of magnesium to magnesium oxide according to the equation? 48 to 80, right? Right?
Yes.
So it's going to be 48 to 80. How many times does 16 go into 48? I want you to use some mental math. How many times? What times 16 equals 48? 3. Thank you very much. You are developing into a chemist. It's a horrid thought, isn't it? But you are. It is. I said that yesterday, but you are. It's 3 times, right? And how many times does 16 go into here? 5 times, right? What's 3/5? What's the decimal equivalent of 3/5? Yeah. It's 0.6, right? So it's 0.6. So this constant ratio equals 0.6. So anything you put in here is going to equal 0.6, isn't it? That's why they call it a constant ratio, right? Yes or no? It's a great example to start with, magnesium plus oxygen. Okay. But we're not starting with 48 grams. I'm leaving off the G. You know it's there. Okay? We're being informal, but okay. How much magnesium are you starting with? 1 gram. Okay. How much magnesium oxide are you going to get? Okay. So solve. What do you get? What do you get? Do it. Do it now. It's kind of the reciprocal, isn't it? Right? Because it's a 1. So I know what the answer is. It's the reciprocal of 0.6, isn't it? Mental math, guys. Chemistry is the only things that are important when you graduate high school. The only things that are important are reading, writing, speaking in front of your peers without fear, and basic mental math. Everything else is gravy. Understood? There was a movie, and it was this kind of a line in the movie. I'm paraphrasing, but the line was that chemistry, I'm paraphrasing, chemistry sustains life. Yes? English and books and literature and anything related to that makes life interesting. Understood? Yes? Okay. What's the answer? Anybody? I need 2 answers. I need a verification. 80 times 1 divided by 48. 1.67. Can we say 1.7? Is that okay? Yeah, 1.7. Let's put that somewhere else. I don't want to put that there. Can I erase this? I'm going to erase this. Is that okay? Yes? Okay, I'm going to put it here. 1.6 grams. 1.7 grams. Is that what we said? 1.7 grams. Yes? I can do that, right? Because you see on the film what the ratios were. You can go backwards, right? Hit rewind. Yes? Put in your calculator. 1 divided by 0.6. What is it? What's 1 divided by 0.6? 1.66, 1.7, yes? So isn't this the reciprocal? A little math exercise. Can you see that? Yes? Get it? Okay. So, it goes from 1 gram to 1.7 grams. How did it do that? How did it do that? Yeah, isn't that weird? I mean, that is really weird, and you're going to do that. In other words, you're going to suck oxygen out of the air and combine it with magnesium with the electron transfers and whatever bonding it is, and you're going to suck the oxygen out of the air and you're going to put it into magnesium and you're going to bond it, and it's going to be a stable compound. Isn't that weird? I mean, I find it amazing. Maybe because I know too much. That's the lab. Understand? That's what we're doing. So what I'm going to do is, you're going to take a piece of magnesium. This is all you're doing today. You're going to take a piece of magnesium. You're going to put it on the small piece. You're going to put it on the electronic balance. You're going to take the mass of the crucible and lid before. Yes? You're going to take the mass of the crucible and lid with the little piece of magnesium in it. Yes? And then, when the experiment is over and cooled, you're going to take the mass of the crucible and lid and whatever's in there. Yes? And then you're going to do some calculations. And then we're going to do the lab for real. This is literally an experiment. This is an experiment of, wow, can I really do this? Understood? Yes or no? End of part 4. Was that good? Yes? Okay.